Okay, I am audible to you. Good morning to all of you. I am audible. Rahul Kumar Singh, Mohit Chaudhary, Asutosh Samrat. Okay, now we are going to start here heat transfer. Rahul, is this your first class? So here we are going to start the heat transfer, and in this subject, after the completion of this subject, we will able to learn how the heat get transferred, what are different modes like conduction, convection, radiation, and we are able to know the basics of design of heat exchangers, condensers, and evaporators. So main purpose of this subject is to design the heat exchanger, design of condenser, and design of reboiler and evaporator, because they are all the heat exchanger equipments, heat transfer equipments, and this is a very important subject for any interview point of view and for any examination point of view. So first of all, I would like to discuss what the meaning of heat here and what the meaning of transfer. So what is heat? How can you define the heat? My dear student, heat is a form of energy in transit. Heat is a form of energy in transit. So actually this is a energy, but it is a form of energy in transit. What is meaning of in transit? Heat is a form of energy in transit due to temperature difference. So if any energy is going to be transferred, means if any energy which get transferred due to temperature difference, that is called as heat in simple language. Clear beta? So heat is a form of energy in transit due to temperature difference. Transit means in transaction. So basically the energy has two classification. Energy can be classified, energy can be divided into two parts. One is energy in stored form, or you can say microscopic form of energy, and basically what I can say, energy can be subdivided in two form. One is energy in transit and energy in stored form. Energy in transit can be either heat and work. Try to understand. Before this I would like to define what energy. Energy can be divided in two form, that is energy in transit, energy in transit, and energy in stored. Transit form of energy is form of some energy. So energy in transit form and energy in stored form. ठीक है बेटा. Energy in transit form can be either heat or work. Heat or work. They are energy in transit. Energy in stored form can be further divided into two form. One is macroscopic form of stored and microscopic form. So it's microscopic and macroscopic. So energy can be stored in two form. One is microscopic and another macroscopic. Microscopic means the energy which are stored at the molecular level. Energy which is stored at the molecular level, that is called as microscopic of stored form energy, and this is energy which is stored due to energy which is stored in form of potential energy and kinetic energy of system, not the molecules, and that is called as internal energy, that I will discuss in thermodynamics. I will not describe here. It's actually internal energy, and microscopic form of energy is the kinetic energy, or you can say the energy associated with the velocity and its position from the reference. तो तो position from the reference its potential energy है ना, and due to velocity means its kinetic energy. That I will discuss later on. I am going to focus on this. This is energy in transit is heat. That's why now then saying ki how can define the heat. Heat is a form of energy in transit that is not sufficient, because heat energy in form of transit is also work. So how the heat is different from the work? Heat is different from the work in the sense, if any energy that get transferred due to difference in temperature, that is called as heat. So now heat is a form of energy in transit due to temperature difference. This is called as heat. Clear beta? So work is also a form of energy in transit, but it's not because of temperature difference. If it is not because of temperature difference, that is called as work, otherwise called as heat. Is this clear? So how we can define the heat that I describe here? बेटा हमने अभी बस ये बताया है कि heat is a form of energy. तो before defining heat, I just define the form of energy. There is two forms of energy is there: energy in transit and energy in stored. Energy in transit can be either heat or work. Energy in stored form can be divided into microscopic and macroscopic. In microscopic form energy, it's called as internal energy. This is called as internal energy. And internal energy is nothing, it's energy associated with the molecular level. And this is called as microscopic form of energy. This is the energy due to velocity of the system and position of the system. So how can define the heat? Heat is a form of energy in transit due to temperature difference, that is called as heat. Clear beta? Any problem? Now from the study of thermodynamics, we will learn that energy can be transferred by the interaction of system with its surrounding. When the system interact with its surrounding, let's say this is what system is there. Prakhat Tripathi, good morning. This is what the system is there, and anything beyond the system is called a surrounding. Clear? And in thermodynamics, we will learn that there is always energy interaction is there between the system and surrounding. Energy interaction is there between the system and surrounding. Either system is closed or open, but there is always interaction of energy is there. Clear? So we will learn in thermodynamics that energy can be transferred by the interaction of a system with its surrounding. When system interact with surrounding, there is a energy interaction is there, energy transfer is there, and these interactions is called as work and heat. So one thing is common in the heat and work. Heat and work are boundary phenomena. What is boundary means? Because what is boundary? System is there. System is the small region in a space. Any small region in a space where we have to focus our attention, that is called as system. So this is what the system is there, and the line which separate the system from surrounding is called as boundary. The line which separate the system from surrounding is called as boundary. And in order to have a transfer of energy either from system to surrounding or from surrounding to system, the energy has to cross the boundary. And there is transaction is there. That's why the heat and work, these two are the form of energy in transit. Why transit? Because and while there is also a stored form. A stored form of energy will not get transferred. This is because it is stored. As long as energy is stored, it cannot be transferred. Once it get transferred, that will be either heat or work. Is this clear? For example, what is stored form of energy? For example, my dear student, if I am saying you have a thermos, a thermos is there, and this thermos is well insulated. This thermos is well insulated. Even the cap is well insulated. Every system is well insulated. Then, and you place the hot water in it. You place hot water in it. A thermos is there. In thermos, you just place a hot water. Then, in this case, whatever the energy has been contained by the hot water, will it getting transferred, or will it get transferred, or is it stored? It is stored. And when I remove the insulation, then what happen? When I remove the insulation from it, yes, it is stored form of energy. And we should say, we should not say it's 20 kilojoule. Let's say I'm saying 120 kilojoule of energy is there. So this 120 kilojoule of it's not correct to say it's 120 kilojoule of heat is there. No, because heat cannot be stored. Heat is a form of energy in transit. Is this clear? We should say 120 kilojoule of energy is there, because once the energy get transferred, when the energy get transferred, that is called as either heat or work. Is this clear? When I remove the insulation, that due to temperature difference, here temperature is 45 and outside temperature is, let's say, 10 degrees Celsius, then that causes the transfer. So whatever 120 kilojoule has been stored, now due to difference in temperature, when I remove the insulation, now it is in transition mode. That is called as heat energy. Is this clear? So as long as any energy is stored, that can neither be heat nor be work. Heat and work, these two forms of energy can only be identified when they are in transfer mode. Clear? So as long as, listen, as long as any energy is stored in the system, that can neither be heat nor be work. When we remove the insulation, when we start to remove the insulation, that causes the energy get transferred due to temperature difference, that can be either heat or work. The main thing is that heat and work, these two forms of energy can only be identified when they are in transit. Yes. Clear? Now, what is difference in thermodynamics and heat transfer? It's very important to know. In thermodynamics also we are talking about the heat transfer, transfer of heat from system to surrounding and surrounding to system. Yes or no? Either heat get in or heat get out. And some moment we have seen some topics of thermodynamics we have seen in the process calculation. Because thermodynamics is simply the law of conservation of energy. Thermodynamics first law simply is the law of conservation of energy principle. Energy can neither be created, cannot be destroyed. It can only transform from one form to other form. So what is the basic difference in the heat transfer and thermodynamics? I told you in thermodynamics we have learned that energy can transfer by the interaction of system with its surrounding. These interactions are called as work and heat. However, thermodynamics deal with the end states of the process during which an interaction occurs. End states means thermodynamics deals with the amount of heat transfer, not the rate of heat transfer. So my dear student, thermodynamics deals with the energy transfer between the end states. Energy transfer between the end states. What is end states? Means when any system change its state from one state to one state 2, and both states are equilibrium states. When we are going to disturb the equilibrium, then system will reach the another state. In between the two states, how much heat get transferred or how much energy get transferred, that we are dealing in the thermodynamics. Okay. But thermodynamics does not provide any information about the nature of interaction or the rate at which that energy get transferred. While in the heat transfer we will able to learn the rate of energy transfer, means the rate at which how fast the energy get transferred, and what are the mode of heat transfer, through which mode energy getting transferred, due to conduction, convection or radiation. Is this clear? The basic difference in the heat and thermodynamics is there. Heat transfer and thermodynamics is there. Heat transfer deals with the rate of heat transfer. Rate of heat transfer. We are able to calculate the rate at which the energy get transferred, or basically heat get transferred. And also it will discuss about. It provides information about the nature of interaction. Nature of interaction means through which mode the energy get transferred. And also in this subject of heat transfer, we will able to learn the temperature distribution, how the temperature profile. We are able to learn about temperature distribution that was absent in the case of thermodynamics. Clear beta? Thermodynamics only describe ki why heat get transferred. Why does the heat get transferred? Why? Because of driving force, and driving force is temperature difference. The answer of why is given by thermodynamics. Why anything is going to happen? Just because of increasing, and every process is going to happen in the universe in direction of increasing entropy, right? So direction of the process, or you can say feasibility of the process, is going to be described by the thermodynamics. Why heat get transferred? Answer of this question is given by why does the heat get transferred? Answer of this question is given by thermodynamics. But how the heat get transferred? How the heat get transferred? How does the heat get transferred? That is answer of this question is given by heat transfer. It is clear. And in thermodynamics, we used to calculate the amount of heat transfer between the two end states. Two end states, one end state, other end states. Means when the system change its state from one state to other end states, to change the states from one state to other state, how much heat should be required or how much heat should be transferred, that is going to be calculated by the thermodynamics. Means in thermodynamics, we are basically calculating the energy interaction or heat interaction between the end states. Clear? While in the heat transfer, we are calculating the rate of heat transfer, and the rate of heat transfer is more important in design of equipment instead of amount of heat transfer. Why the rate is important? Because for example, if you want to design a thermos, okay beta, why in the designing of heat exchanging equipment or heat transfer equipment, the rate of heat transfer is important instead of amount of heat transfer? Because we are, with the help of rate of heat transfer, we are able to know ki how fast. Let's say I'm saying ki I have a thermos, and we just insert the water at temperature of 45 degrees Celsius, and at the end of the day, here water temperature reached to, let's say, 35 degrees Celsius. It means in 24 hours, let's say in 24 hours, then, and surrounding temperature is of 10 degrees Celsius. So in this case, what is important? Because obviously after 3 to 4 days, even the temperature has to be reached to, the temperature of water has to be reached to 10 degrees Celsius. Yes or no? But important is not the amount. Important is how fast or how slow the energy get transferred. We can qualify, or we can say the best thermos is the thermos which allow the rate of heat transfer to be very slow. Yes or no? Which thermos is best for you? For example, let's say if one thermos is there which makes the temperature 45 degrees Celsius to 35 degrees Celsius in 24 hours, another thermos is there which makes the temperature of 45 degrees Celsius to 10 degrees Celsius in 24 hours, then which thermos is best for you? You want to keep the water at temperature of 45 degrees Celsius because we are in the cold season and we want to maintain the temperature of 45 as long as possible. Then here, why it is best in the sense of here the rate of heat transfer is slow and here the rate of heat transfer is fast. So that's why I'm saying that designing here, what is important? Rate of heat transfer is important because amount of heat transfer will be same in the both cases at the end of 3 to 4 day. Yes or no? Amount of heat transfer, even this thermos after 3 to 4 day, after 3 day, again the water temperature will be dropped to 10 degrees Celsius. Yes or no? But here in this thermos, the water temperature dropped to 10 degrees Celsius after 3 day, and in this thermos it's dropped to 10 degrees Celsius only in 1 day. So ultimately amount of heat transfer in 1 day and amount of heat transfer in 3 days is same. Yes or no? MCP in reality. Initial temperature, final temperature is same, mass is same, CP is same. Yes or no? Amount of heat transfer is same in the both cases. Yes or no? But what is difference? The rate of heat transfer is different. So in designing of any equipments, the rate is important as instead of amount. Is this clear? And also the advantage of studying this subject, we are able to know the temperature profile, temperature distribution, how the temperature variation is there. Okay. So this is what the objective of studying this subject. Is this clear, beta? How the heat transfer is different from thermodynamics? So here heat transfer and here thermodynamics. Some points better is that first in the heat transfer we are able to know how do the heat get. The answer of this question we are going to discuss in the how does heat get transfer, rate of heat transfer, temperature distribution, and in thermodynamics why does heat get transferred. Discuss the amount of heat transfer, between two end states. Okay, so that is what the basic difference in thermodynamics and heat transfer. Why does the heat get transfer? Answer of this question is given by the thermodynamics because of temperature difference. Amount of heat transfer, it calculates the amount of heat transfer between two end states. Means when the system changes states from 1 to 2, 1 equilibrium state to second equilibrium state, then in order to change how much heat should be required, that is the amount calculation. Amount of heat transfer calculation is important in the thermodynamics between two end states, while in the heat transfer we are interested in the calculation of rate of heat transfer instead of amount of heat transfer. Clear, beta? Okay, now so we are going to start basically the heat transfer, and the heat transfer is basically the thermal energy in transit or energy in transit due to temperature difference that I told you in the very first. If anyone has told you how can you define the heat transfer, what you should say? Heat transfer is a form of energy in transit due to difference in temperature, or heat is thermal energy in transit due to a temperature difference. Clear? And whenever a temperature difference exists in the medium, there is always a heat transfer occurs. And now modes of heat transfer. Modes of heat transfer means how the heat get transferred. What are different modes? So modes of heat transfer is conduction, convection, and radiation. conduction, convection and radiation. In simple language, how can you define the conduction? When a temperature gradient exists in a stationary medium, when a temperature gradient exists in a stationary medium, stationary means what? Any medium which has no any bulk motion, any medium in which there is no bulk motion is there. The two types of motion is there. One is molecular motion, another is bulk motion. Listen carefully. What is molecular motion? Let's say if I just place a water in a pan, water in a pan is there. Clear beta? Water in a pan. Then is there any bulk motion? If we just place a water in a pan, is there any bulk motion? Is there any molecular motion? This medium is called a stationary medium. But there is always a molecular motion is there, because it is a fluid, and you know the tendency, you know the property of the fluid, ki fluid molecules are always in the motion. That's why they are in fluid. When they get freeze, it becomes solid. है ना? So molecular motion is always there. Molecules of the water is always going to move randomly here and there. Yes or no? There is always molecular motion, but there is no bulk motion. Bulk motion means any motion that is going to induce by the external or due to any other sources. That is bulk motion. So molecular motion is always there whenever I am talking about the fluid. Means in the liquid and gases, the molecules are always in the motion, that you know. So I am not talking about that motion. I am talking about here, if I am saying कि medium is stationary. So stationary in what sense? Stationary as in the microscopic point of view. Means in the microscopic point of view, at the microscopic level, molecules are always in the motion. So what is the microscopic level? Microscopic level means which we are seeing as a naked eyes. We are not able to observe the molecular motion with the naked eyes. Yes or no? So at the microscopic level, MA, at the microscopic level, the molecule, there is no any bulk motion is there. That's why it's called as stationary medium. Clear beta? So conduction will always occur when a temperature gradient exists in a stationary medium, and the medium may be either solid or a fluid. Clear? So conduction is possible in solids as well as in the fluids, but the condition for the fluid to be that fluid must be stationary, means there should be no any bulk motion. Clear? I am not talking about molecular motion, I am talking about bulk motion. Means there should be no any motion at the microscopic level which we can observe with the human eyes. Clear? As far as conduction is concerned, when a temperature gradient exists in a stationary medium, which may be a solid or a fluid. Clear beta? When a temperature gradient exists in a stationary medium which may be a solid or a fluid, we use the term conduction. We use the term conduction to refer to the heat transfer that will occur across the medium. We use the term conduction to refer to the heat transfer that will occur across the heat transfer that will occur across the medium, or in simple language you can say medium. Any heat that get transferred across the medium, across which medium? Any heat transfer that will occur across the stationary medium because of temperature gradient, that is called as conduction. Clear? So whenever a heat transfer that will occur because of temperature gradient in a stationary medium, that energy transfer is called as, that heat transfer is called as conduction heat transfer, or via conduction. So for conduction to be takes place, the condition should be that medium should be stationary. Clear beta? And that will, conduction is possible either in the solids or in the fluid. Clear hai ki nahi? In the solids, molecules are always stationary. Molecular position is fixed at their location. So obviously there is no any bulk motion of the molecule is possible. But in the fluids, bulk motion in the molecule is possible when we use external sources. For example, if I using a stirrer, in that causes the bulk motion in the fluid. Yes or no? The two types of motion is there in the molecules. One is the microscopic motion and another macroscopic motion. So microscopic motion means that the molecular motion that is always there. But at the microscopic level, there is a motion is bulk motion. So whenever in the fluid, if I am talking about the energy transfer or heat transfer due to temperature gradient in the solids, that is only due to conduction. Because in the conduction, the condition should be medium must be stationary, and in the case of solids, the medium is always stationary. But in the fluid, if you want to have a conduction medium or conduction mode of heat transfer, then the condition should be कि the medium must be stationary. Is this clear? Means there should be only molecular motion. There should be no any bulk motion in the molecules. Clear beta? Bolo. This is basic simple definition of conduction. Now how can define the convection? So one thing is very important that to be noted, कि conduction is possible in solid as well as in the fluid. But the condition for the conduction heat transfer is the medium must be stationary. And if in that types of medium, in that stationary medium, if there is a temperature gradient, that heat transfer is called as conduction heat transfer. Now, how can define the convection? Convection terms refers to the heat transfer that will occur between the surface and a moving fluid. My dear student, convection heat transfer occurs between a surface and a moving fluid when they are at different temperature. Means that is how can define the convection in one line. Convection is a transfer of heat or transfer of energy, you can say. Convection is a transfer of energy between surface and flowing fluid over it when both are at different temperature. Means fluid flowing and the surface over which the fluid is flowing, if both are at different temperature, then there is a convection. Clear beta? And you know, when the fluid is in the motion, if any fluid is flowing over any surface, let's say for example, so basically before this, yes, let's say this is what, you should not draw this. I'm just going to define the first convection. Convection refers to the heat transfer occurs between a surface and a moving fluid, when they are, because for energy heat to be transfer always there should temperature difference, है ना? So that is only correct when the moving fluid and the surface are at different temperature. When they are at same temperature, then it is possible to have a heat transfer, because driving force for the heat transfer is the temperature difference. Temperature difference should be always there in all three modes of heat transfer, because main driving force for the heat transfer is temperature difference. When, because thermodynamics has told ki why does the heat get transferred, just because of difference in temperature. Whenever there is a temperature difference is there, then heat will get transferred. Now, but due to temperature difference, the three modes are there, three ways are there for the heat to be transferred because of temperature difference, है ना? So one is conduction. The conduction is the transfer of energy due to temperature difference when the medium is stationary. When temperature gradient or temperature difference, you can say also, when temperature gradient exists in the medium, when in which medium? In a stationary medium. So whenever I am talking about conduction, the one term is very important, that is stationary medium. Stationary medium, not medium, stationary medium. So conduction is the transfer of energy or transfer of energy due to difference in temperature between the stationary medium, or whenever temperature gradient exists in a stationary medium, there is a term called as conduction, through which the energy get transferred. Convection terms refers to the heat transfer occurs between the surface and moving boundary when they are at different temperature, है ना? When a surface and a moving fluid are at different temperature. Clear, beta? So here the fluid is, here I not told you medium, here I told you fluid. Listen, every word is very important. Here I told you fluid, and the fluid is not, and here I talk about fluid as well as solid. That's why I told you the common word as a medium, and this medium is either solids or fluid, but the medium must be stationary. Clear, beta? So conduction is possible in the solid as well as in the fluid. In the fluid, if I am talking about conduction in the fluid, the medium must be stationary. Now, while as far as convection is concerned, in the convection the fluid is moving fluid, and it's only in the fluid, it's not in the solid. Convection can never be possible in the solid, because convection refers to the heat transfer occurs from a surface or to the surface, or between the surface and the moving fluid, when a surface and moving fluids are at different temperature. Clear? And the third mode of the heat transfer is called as radiation, and basically it's thermal radiation. And all surfaces of finite temperature emits the energy in form of electromagnetic wave, quantas. And that's why in the absence of any intervening medium, there is a net transfer by the radiation between the two surfaces of different temperature. And third is radiation. It's just a basic difference. All surfaces which are at the finite temperature, they will emit the energy in form of electromagnetic waves, that is called quanta. And hence, in the absence of any intervening medium, there is a net heat transfer occurs by radiation only between two surfaces which are at different temperature. So all surfaces of finite temperature means the surface in convection. So surface is of only solid. All surfaces of finite temperature emits energy in form of electromagnetic wave. Electromagnetic wave, also called as quanta of photons. Hence, in absence of an intervening medium, there is net heat transfer by radiation between two surfaces at different temperature. Listen, if the two mediums are there, let's say two surfaces are there, they are different temperature. There are two surfaces. They are at temperature T1, this is at temperature T2. And there is no any medium is there. There is no any intervening medium. No medium is there. Means complete vacuum is there. But if the two surfaces are different temperature, then energy get transferred through only radiation. So what you have seen, one very interesting thing in the radiation is that in the radiation the medium is not important. Medium is not compulsory for the energy get transferred, because I told you कि all surfaces which are at finite temperature always emits the energy in form of electromagnetic quanta, and to transfer the electromagnetic quanta there is no requirement of energy. A medium is not important. Medium is not required for propagation of photons. Clear beta? So net energy that get transferred between the two surfaces which are at different temperature, that without any medium, that is only through radiation. While in the upper two, means in the first two mode of heat transfer called as conduction and convection, medium was compulsory. Medium was solid and fluid in the case of conduction. Medium was only fluid in the case of convection. Yes or no? Medium was only fluid in the convection, while there is no medium is there in the radiation. Means medium is not compulsory for the energy transfer or heat transfer due to radiation. Clear beta? So do you got some basic information about the conduction, convection and radiation? So through wire figure I am going to describe here. Let's say for example, this is what the plate is there, and if within the plate the fluid is stationary, what here the fluid is there, in between the two plates a fluid is filled, and let's say we are going to consider fluid is stationary. Here this is what is stationary fluid, and this plate is at temperature T1, this plate is at temperature T2, and T1 is more than T2, means hot plate and cold plate. Left plate is hot and right plate is cold. T1 is more than T2. Then obviously there is a heat transfer in that fluid medium or in solid also. Here also, although it is fluid, but this medium may be essentially medium, I should say medium. It may be either fluid or solid. Clear? Then energy get transfer is just because of conduction. Okay? Let's say a fluid is encapsulated in between. I will discuss one more thing here. So if medium is, as long as the medium is stationary, then the heat transfer between the across this is only through conduction. For the convection, I told you convection is the mode of heat transfer which occurs between the surface and the flowing fluid. Let's say this is a flat plate is there, and fluid is flowing across it. It's a moving fluid at temperature T infinity, and the surface temperature is maintained at the constant temperature Ts. Let's say anyhow we just maintain the surface temperature as a thermal condition of Ts, surface temperature, and as the fluid flows over it, my dear son, there is a formation of boundary layer that you know very well, and this is called as velocity boundary layer. So let's say for example, and here the velocity is u infinity. Clear beta, that I already told you. U infinity is the free stream upstream velocity, and this is upstream temperature, and Ts is, if Ts and T infinity are equal, if Ts and T infinity are equal, then what happens? There is no heat transfer, but there is a momentum transfer is always there. We have already seen there is a momentum transfer, and due to momentum transfer there is a formation of boundary layer. So this is what velocity boundary layer. This is called as velocity boundary layer, or also called as momentum boundary layer, that we have already seen in the fluid mechanics. Because whenever fluid get flows, there is a formation of velocity gradient, and there is a momentum transfer which causes the shear stress distribution like this. So this is not the energy transfer, this is the momentum transfer, this is velocity boundary layer. But when the fluid flowing over the surface is at different temperature, let's say I am saying Ts is more than T infinity, means surface temperature and fluid flowing over it is at different temperature, then there is also simultaneous formation of heat transfer along with the momentum transfer. Clear? So this is what the profile for its velocity profile, my dear student. It's a velocity profile. And due to no slip condition, you know velocity is 0 at the surface. Clear beta? This is what the y, and this is what x. Now when Ts is more than T infinity, then along with the momentum transfer, along with the velocity boundary layer formation, there is also thermal boundary layer formation is there, or temperature heat transfer will be there. Yes or no? So listen, at the same I am talking about the temperature distribution. Obviously any fluid layer at the surface of solid will be in equilibrium with the surface of solid because they are in direct contact. Yes or no? Any fluid layer, let's say I am talking about surface temperature is at different temperature and T infinity is a different temperature. So any fluid layer which is just on the surface of solid will be the same temperature as of the surface. Bolo, please tell me. Because of thermal equilibrium will be there. Any fluid layer, I am talking about a layer of the fluid adjacent to the surface of solid, just adjacent. So they are in the same temperature. No? It means if I am talking about this is axis, then here temperature is this, it's Ts, and as we are moving in the y direction, temperature get decreases, like this, temperature get decreases, and there is some thickness is there where temperature reach to the. So this was velocity, this was delta. Delta is called as velocity boundary layer thickness. Now, and this is called delta Th. What delta Th is there? This is called as delta Th, thermal boundary layer thickness. So thermal boundary layer thickness, how can I define? Ki as we are moving in the y direction, temperature get decreases, and once it reaches to the 99% of upstream temperature, that thickness is called as thermal boundary layer thickness. Clear? Yes or no? तो दिस इज व्हाट जो ब्लैक वाला है दैट इंडिकेट्स यू u is a function of y, and the red indicates you the t as a function of y, temperature variation as a function of y. Is this clear? So red line indicates you the thermal TBL, thermal boundary layer, है कि नहीं? बोलो. Just like a momentum transfer, there is also heat transfer. Why the heat transfer will initiate here? Because any layer of the fluid just on the surface, listen, the first layer of the fluid which is on the surface of solid will be at temperature of Ts, but any other layer of the fluid is at different temperature, and that temperature difference in the fluid, causes temperature gradient, and due to this temperature gradient there is an energy get transfer, and that energy transfer is through convection, not conduction. Why not conduction? Because fluid is in the motion. Yes or no? Here, because of, listen, The surface temperature is differ from the fluid flowing. Ts is more than T infinity. So if you see in at the through a microscope, or you can say at the exaggerated level, if you're going to enlarge this condition here, then this is what your surface is there. This is what your surface. This is at temperature of Ts, and any fluid layer here, it is also at temperature of Ts. Let's say Ts is 100 degrees Celsius, and the red is fluid flowing over it, and the different layer of the fluid is there. One layer, this is another layer, another layer, this is another layer, and all the layer of fluid is at different temperature. It's 100, it's 98, it's 96, like this. So this causes temperature gradient in the fluid. The temperature gradient in the fluid occurs here. It means temperature decreases like this. Yes or no? As we are going to move in the y direction, temperature decreases like this. So this causes temperature gradient in the fluid. So temperature gradient occurs. It means if you see, there is a dt upon dy. Yes or no? Just like in the momentum transfer, there was velocity gradient. As any fluid come to the surface will come to the rest, but any other fluid just above that will be in some motion, will have some velocity that causes the velocity gradient, and that causes momentum transfer. Similarly, any fluid layer just on the surface of solid will have the temperature of surface, but any other fluid layer which are not in direct contact with the surface will have some different temperature. That causes the temperature gradient. dt upon dy, it's temperature gradient, and whenever temperature gradient will exist, there is always get heat transfer. Yes or no? But why the heat transfer is not through conduction? Anyone? Because in that case the heat transfer is through convection, because the fluid is in the motion. Fluid is not stationary. Am I right, my dear student? Because fluid is flowing with some velocity. Fluid has some velocity. Fluid is forced to flow. So that's why similarly there is a formation of thermal boundary layer. I will discuss in more detail later on. Is this clear? Yes or no? How the temperature profile will develop here. And this dt upon dy is not same throughout. It is going to change from location to location. Sir, you can think yourself, sir, if T infinity more than Ts, sir, it's common sense. You should not ask to me. Velocity profile will be as it is. It's a velocity profile. Its velocity boundary layer will be as it is, because velocity profile will simply form because of when velocity becomes 0. This is an arrow is only in the case of momentum, because momentum is a vector, but heat is not a vector. Temperature is not a vector quantity. Temperature is scalar function. So velocity I shown here. Now as far as temperature, if T infinity is more than Ts, the fluid flowing over it, it's T infinity, and this is what Ts. And if T infinity is more than Ts, then what happen? I am going to show through black color here. So obviously, if this is the axis, let's say at this location of x, I am going to draw the temperature profile and velocity profile. This is what velocity profile. It's u is a function of y. Now how the temperature is going to vary? Obviously at the surface, at y equal to 0, temperature is less. It's Ts here. This is Ts. Any fluid layer on the surface will be in equilibrium with the surface, that is Ts. And as we are moving upward, temperature gets changed. Temperature get increases, yes or no? And then it reaches to the. So this I am not going to write arrow here. Its simple profile is there. It's Ts, and this is T is a function of y. Temperature get increases, and then when it reaches to the T infinity, then this is called as thermal boundary layer thickness. Is this clear, Mr. Astos Verma? But it will not start from 0. That's more important thing, is that it will not start from 0, because even at the y equal to 0, there is some temperature, that is surface temperature. Clear, sir? So what happen in the fluid, the temperature gradient will develop, and in that fluid, since the fluid is in the motion, that's why that temperature gradient occurs, causes the heat transfer through convection in the fluid. Is this clear? One very common example is there. If you are going to let's say if you have a hot boiled egg is there. Clear beta? This is hot boiled egg, and if you allow the hot boiled egg in the atmosphere, then air is flowing. Let's say air is flowing in this direction. Let's say you place a fan over it. This fan makes the air to force to flow. Yes or no? So there always the fluid is in the motion. So any fluid layer, how the boundary layer will develop, how the thermal boundary layer and velocity and temperature all will develop here. Whenever any fluid come to the surface of the axle, that velocity becomes 0, and as the fluid moves away from the surface, the velocity get increases. This is what the velocity boundary layer. Yes or no? This is what the velocity boundary layer. Because any fluid layer which comes to the surface of solid, of surface of axle, that will have 0 velocity, and as we are moving upward in the y direction away from the surface of axle, the velocity get increases, and this is what we call as velocity boundary layer. Now what about thermal boundary layer? As far as temperature is concerned, any fluid layer on the surface of solid will have the same temperature as of surface, and as we are moving upward, temperature get decreases. So this is what the temperature distribution. So here this is temperature distribution is there. Yes or no? T is a function of y, and this is U is a function of y. So this is what the example. It means again you can see here the convection is the transfer of energy between the surface of solid surface and the flowing fluid. So it may be at the flat plate, it may be at the curved plate, or it may be of any surface. Any hot plate is there. Let's say if you have a curved hot plate, and means the only condition is that the fluid and surface temperatures must be differ. Then only the energy will transfer. Otherwise, heat will not transfer, because for the heat to be transferred, there should be always temperature difference. So if it is curved surface is there, it's curved surfaces, and here it's temperature Ts, and here the fluid moving T infinity, and Ts is not equal to infinity. Then if the fluid is flowing over it, that causes the convection heat transfer. Why convection? Because fluid is in the motion. That causes the temperature distribution, and either to the surface or from the surface of the fluid. So energy get transferred between the fluid and surface, and direction of the heat transfer will decide by which temperature here, because heat always transfer from the high temperature to low temperature, that you know from thermodynamics. Yes or no? So in this case, the energy get transferred from surface to fluid. This is what the direction of Q is here. This is what direction of Q I am going to write here. It's direction of Q. Here the Q is here in this direction. This is the heat transfer to the plate or to the surface. Here heat transfer is from the surface. Clear? So this is what the convection. So convection is the transfer of heat between the surface of solid and flowing fluid over it. This is what the convection. Clear beta? Any problem? कुछ clear हुआ? Yes, very nice question. Can conduction and convection occur simultaneously? That depend upon the condition. For example, Prajyot Gajavie, simultaneous means conduction and convection occur simultaneously. Listen, as you ask me कि can conduction and convection occur simultaneously. Listen, first of all, convection is not a phenomena. Convection is simply conduction with bulk motion. I will describe convection in more detail. Listen, my listen. convection is what? How can define the convection? If Ts is less than T infinity, sir, I told you here, if Ts is less than T infinity, then heat transfer from flowing fluid to the plate is obviously convection, sir. Sir, this is all our convection. As long as the fluid is in the motion, there is a convection is there, Mr. Amrit Sagar. Sir, for the convection to be takes place, the only condition is fluid should be in the motion. Listen, convection is nothing, it's simply conduction plus bulk motion. Mr. Prajjot, listen, convection is not a phenomena. Actually, convection is nothing, it's conduction along with the bulk motion. Means when the conduction is assisted by the bulk motion, that is called as convection. Because if you observe carefully, the definition of conduction I told you, कि conduction is the transfer of energy or transfer of the heat between the stationary medium, and the medium, as long as medium may be either solid or in the fluid. Solid or fluid. But this all medium must be stationary. That I told you. So what is differ in conduction and convection? The only differ in the motion. Yes or no? So whenever the conduction is going to assisted, whenever conduction heat transfer was taking place, means fluid was initially in stationary motion, and when it is going to be assisted due to bulk motion, that phenomena is called as convection. Clear? Means if anyhow we are able to maintain the motion, we are able to induce the motion in that stationary fluid medium, that is called as convection. And the bulk motion in the molecules you can't create in the solid molecules. Yes or no? Because molecules of the solids are always fix its position. Molecules of the solids are fixed. Molecules in the solids are always fixed at their position. The only motion that you can create is in the fluid. It is clear, beta? That's why convection is only possible in the fluid, not in the solids. So convection is not a phenomena. Convection is simply conduction along with the bulk motion. Clear? When the bulk motion is absent, that convection, that we should not say convection, because convection will come into picture only when the fluid is in the motion. Clear, beta? Or in other words, you can also say convection is nothing, it's conduction plus advection. Conduction plus advection. What is advection? Do you know? Advection means motion in the fluid. Advective flow. Bulk motion. Advection means bulk motion or motion in the fluid is called advection. And when the bulk motion in the fluid is going to be takes place along with the temperature difference, because conduction is only possible due to temperature difference, and when that temperature difference or when that heat transfer by conduction is going to be assisted by the bulk motion or advection, that is called as convection. Clear, beta? So when there is no advection is there, then the only heat transfer is through conduction. Pure conduction is only possible when there is no any bulk motion is there. Clear, beta? Bolo. Now the question is, how it is possible to have a pure conduction in the fluid? Conduction in the solid is very common. Yes or no? Because for example, if you are hitting a rod, let's say a rod is there, it's one end and it's another end of the rod. If you are keep burning, if you place this end of the rod at the burner or let's say this is the fire is there, if you keep burning, keep hitting this, then obviously the molecules in the solid, let's say this is a solid rod is there, solid bar, it's a bar, then molecules in the solids are at the fixed at its position. What is mechanism of conduction that I will discuss later on. I am just describing how the conduction. Then the molecules are fixed at their position. There is no any bulk motion is possible. Then and as we hitting the temperature at this side will be get more T1, here T2 and here T3, here T4. Then obviously T1 is more than T2 is more than T3 is more than T4. That causes the temperature gradient, and if it is x direction here, then that causes dt upon dx. Yes or no? Temperature gradient. temperature variation in x direction. And when the temperature gradient will exist, that I told you, definition of conduction. Conduction is the transfer of energy or transfer of the heat in the stationary fluid medium due to temperature gradient, or whenever temperature gradient exists in a stationary medium, that causes the conduction to be takes place. So conduction is the transfer that I told you. When we start heating, the molecules of solid are fixed at their position, and at this point temperature is T1, at this point temperature is T2, and T1 is more than T2. Then obviously that causes the temperature gradient dt upon dx, and that dt upon dx is temperature gradient, and that causes the energy get transferred, and that is called as conduction. Clear? Bolo. Is there any motion in the molecules? No. So convection can never be possible in the solid, because convection is simply conduction with bulk motion. Whenever that's why Mr. Prajot, as you ask me, is it possible to have a conduction and convection simultaneously? है ना? So is it possible? No, because from this discussion your answer should be no. Conduction and convection can never be happen simultaneously, because convection is not a phenomenon. Convection is simply conduction with bulk motion. Mr. Praveen has been asked, sir, when one solid is rubber and on the other solid, that heat transfer takes place, is that big? Means I am not getting your question. ये क्या भाई? Sir, when one solid is rubber on the other side, means one solid is rubber on the other side, then heat transfer is what? Where is rubber? One solid is rubbed. Rubbed means I am not getting your question. Rubbed means what? Please ask again. Please ask again. Means rubbing of hand. सर कन्वेक्शन समझते हो क्या होता है यार? जहाँ पे मोशन होगा मेरे भाई. सर रबिंग ऑफ टू सॉलिड रॉक. सर लिसन, you are not able to understand, my dear student. Sir, if you are rubbing the two solid blocks, this is simply transformation of energy. Sir, it's energy. It's the first law of thermodynamics. कि mechanical energy is converted into the heat energy or thermal energy. This is the thermal energy, because if you rub your hands, then you are transforming. It's the first law of conservation of energy principle. कि energy can neither be created, cannot be destroyed. You are just transforming the mechanical energy by rubbing your hand into the thermal energy. And that thermal energy, whatever thermal energy has been generated, that thermal energy get transferred from the high temperature to low temperature. That is through either conduction or convection or radiation. That is different part. For example, if the two side block is there, and if you are rubbing, through rubbing what happens? The heat will get generated. Mechanical energy is converted to thermal energy. But what happens in that solid block? The energy get transferred from this side to this side due to what? Conduction. Whatever energy has been generated at the in between this at this position, that energy get transferred from this wall of the solid to the other wall of solid due to what? Because this wall is at high temperature. Wherever you have rubbed directly, means at the center the temperature is higher and here temperature is lower. T1 and T2, they are different temperature. That causes temperature gradient. And temperature gradient, is there any fluid motion in the solid? Tell me please, is there any fluid motion is there in solid? So obviously the heat transfer through conduction only. So that transfer of energy due to temperature gradient in that medium where no fluid motion is there, there is no any more, because there is no fluid is there, and if solid is there, there is always conduction. You should have a doubt only in the fluid, कि how the conduction is possible in the fluid. Conduction is always in the solid. There should be no any doubt, because the molecules in the solids can never be in the motion. Your doubt should be only in the fluid. Clear, sir? Now at the same time, let's say if this is the rod you have heated, try to understand. I am talking about if you are heating the rod from this side, then obviously the temperature energy get transferred from this side to this side, from high temperature T1 and this side T2. But as the rod get heated, then any fluid flowing over it, in that energy get transferred through convection. Yes or no? Conduction in the solid, But as the rod get heated, obviously the whatever rod get heated, temperature of the rod get increased. Then and temperature of surrounding fluid is lower. Then again this is the convection, because convection is the phenomena of transfer of energy between the surface and the fluid. Then any fluid to surround the solid surface will also get heated, or energy get transfer in the flowing fluid surrounding surface via convection, because fluid surround the solid surface in the motion. Clear? But within the solid, conduction is there. Through solid there is a convection. Within the solid, or you can say through the solid there is conduction, but from the solid to the flowing fluid there is a convection is there. Clear? Now as Mr. Prajot has asked, is simultaneous. Now simultaneous is possible in this case. Listen, in this case simultaneous, for example, if you have a rod, try to understand. If you have a rod and you just keep hitting this rod from this side, then what happens? There is a conduction is there and there is also convection is there. Then simultaneous heat transfer is through Q conduction and there is Q convection. But in the same medium, it's not possible to have a simultaneous heat transfer. Same medium is here in the in this fluid, it's not possible to have a simultaneous conduction and convection. Are you getting? Here in this case possible कि whatever energy get transfer here from this side, the energy get transfer within the solid through conduction, and from the solid in the surrounding fluid via convection. Is this clear? The total energy that get dissipated from this side, total energy that get transfer. Are you getting a point? Yes or no? For example, listen once again. This is the rod is there, and if I am going to heat the rod from this side, then at any cross section, let's say at any cross section x from this distance, here energy get whatever energy get transfer at this point. मान लो at x पे जो भी energy गया in this section of the rod, whatever energy, let's say 100 kilojoule of energy has been entered per second. Let's say, try to understand. Very simple, very logical question is there. Let's say this is the rod and this get heated from here. I am going to talk about any section x distance from the fire जहाँ से हमने heat किया है. In this section I am talking about the heat transfer. Let's say through conduction in a Q conduction at x is let's say 100 kilojoule per second. ठीक है बेटा? The rate at which energy get transfer in this section is via conduction is 100 kilojoule per second. So whatever energy get transferred through conduction at that section, that will get propagate through conduction again here. Is this again 100? No, because here energy get also get transferred through its perimeter via convection, because here the fluid is in the motion. Yes or no? Its Q convection is there through its perimeter. So this, if it is 80 here, then this would be here 20 here. So this 100 equal to 80 plus 20 means Q conduction at x is equal to Q conduction at x plus delta x plus Q convection. Is this clear beta? So this is simultaneous conduction and convection is taking place in this example. Conduction through this, if within the solid conduction is there, and from the solid in the flowing surrounding fluid there is a convection is there. Because it's very common to say कि by 100 kilojoule per second 100 watt energy has been entered here, then all 100 will not be. Now if you want to reduce the convection, if you don't want to have any convection, you should insulate, you should provide insulation here. This curved surface should be perfectly insulated. Are you getting my point? Curved surfaces must be perfectly insulated. If curved surfaces you make perfectly insulated, then there is no heat transfer through curved surfaces. Then whatever 100 kilojoule is there, all 100 kilojoule should be coming out through conduction only. Clear beta? There is no convection is there, because your perfectly insulation is there. So convection is basically conduction plus bulk motion. Why I am saying here, where is there convection? Now here again in this case I told you why. Let's say this is what is phenomena. Why I am saying convection is conduction plus bulk motion. So I am not talking about this conduction. I am talking about if I exaggerate this here, this is the pipe wall. So any fluid layer on the surface will be stagnant due to no slip condition. Any fluid layer on the surface of solid is stagnant. Yes or no? This is the fluid layer. It is stagnant. So when the fluid layer is stagnant, then here the heat transfer is through only conduction on the surface. on the pipe wall, I'm going to consider this here, this section. It's a pipe wall is there. I'm talking about this wall. इस wall को मैं यहाँ दिखा दिया आपको. तो any fluid layer on the surface of pipe wall will be stagnant due to no slip condition. But as we are moving upward, what happened? The fluid is in the motion. Its velocity get increases, and when the velocity get increases, then it's also causes the temperature gradient. Velocity gradient causes temperature gradient. Yes or no? Due to velocity gradient, there is also always temperature gradient is there. If the temperature of the fluid is different, I'm not saying कि temperature but condition must be there कि temperature of the flowing fluid should be different from temperature of surface fluid, surface. Then only the energy get transfer. But what I'm saying to you, when the temperature of the fluid and surface is differ, and if there is a velocity gradient, that velocity gradient causes also temperature gradient. And due to this temperature gradient, there is always also heat transfer is there. Is this clear? So if I'm talking about at y equal to 0 plus means just on the surface of solid, surface of the pipe wall, the heat transfer is through only conduction because the layer of the fluid is stagnant. So heat transfer will be initiated by conduction, but due to motion in the fluid, so at the first layer of the flowing fluid, the heat transfer is through conduction. I will discuss again, but here let me discuss here again. I'm talking about again convection and immobility. Let's say this is the surface is there, and here it's x, and this is what the y, and this is the fluid flowing past the surface. Let's say any hot plate you kept and just air is flowing over it. This is what the air is flowing with the velocity of u infinity, temperature is T infinity, and here temperature is Ts, surface temperature is Ts, and I'm saying here Ts is more than T infinity. Heat transfer is from the plate to the flowing fluid. Now there is two boundary layer formation, simultaneous formation of velocity boundary layer and thermal boundary layer. Why thermal boundary layer will form? Because of temperature is differ. If temperature would be same, then there is no formation of thermal boundary layer, only formation of velocity boundary layer is there. So already we discussed in the fluid mechanics, there is a formation of velocity boundary layer, and this is what the velocity boundary layer, and that I shown you. Any fluid layer on the surface will have zero velocity, and as we are moving upward, velocity get increases, and that causes the velocity gradient, and here the gradient will exist in that. This is called as velocity boundary layer region or boundary layer region, and this is u is a function of y. ठीक है बेटा, any problem? यहाँ पे zero velocity है. Now as far as temperature boundary layer is concerned, temperature distribution is concerned, any fluid layer on the surface will have a temperature of Ts, and as we move away from the surface, temperature get decreases, temperature get decreases like this, temperature get decreases. Let's say at this thickness temperature become 99% of T infinity, then this is called as thermal boundary layer. The two boundary layer has been formed, one is velocity and thermal. This is thermal boundary layer, this is velocity boundary layer, this is T as a function of y. Now come to this picture. What at y equal to 0? At y equal to 0 plus, at y equal to 0 plus means not 0, just adjacent to the surface of solid, the fluid is nearly stagnant. At y equal to 0 is stagnant, but at y equal to 0 plus, just immediate surface, fluid can be assumed to be stagnant, nearly stagnant. At y equal to 0 obviously stagnant, but at y equal to 0 plus, just adjacent to the surface of solid, the fluid is nearly stagnant. In that case the heat transfer, because when the fluid is stagnant, then heat transfer through conduction or convection. So if I'm talking about in that layer, the energy get transferred through conduction, so Q should be through conduction, heat transfer through conduction only. But as we move away from the solid, far away from solid, then fluid, you found that fluid is in the motion, the velocity of the fluid get increases. As you move away from the surface solid, what happened? We found the fluid is in the motion. Then that is the series in the series means the whatever the energy get transferred through conduction at the wall, the same rate energy should be propagated by convection in the fluid, because now the fluid is in the motion at y equal to far away from surface of solid. The heat transfer through convection, because now fluid is in the motion. So can you say at y equal to 0 plus q conduction equal to q convection? Here conduction and convection, they are in series, means at the wall the heat transfer is through conduction, but in the rest of the flowing fluid the heat transfer through convection, means the rate at which the heat transfer from the surface to the fluid ascent to the surface is through conduction. The same rate जो भी एनर्जी का ट्रांसफर थ्रू कंडक्शन से हुआ यहाँ पे, that is going to be transferred in the rest of the fluid via convection. Clear? Heating, a simple example, if you are heating the water in a pan on a gas or on an electric heater, let's say this is a heater is there, let's say a hot plate, if you keep your, let's say you are going to heat the water to make a tea, what happen? Any fluid layer on the surface of the pan, first of all, heat transfer through conduction will take place within the thickness of the pan. There is some pan thickness is there. Let's say this is the pan thickness. This is some thickness of the pan is there. Okay, beta. Now in that thickness of the pan, the heat transfer is through. In this thickness of the pan, the heat transfer is through conduction. Yes or no? This is the metal and it is solid. Then heat transfer is through conduction only. Q conduction. This is at temperature T1. This side surface is at temperature T2. This temperature difference causes the temperature gradient, and that causes conduction in the solid. Now, once the heat transfer to conduction is there in the metals, now when this is at temperature T2, and now the fluid adjacent to the surface is also at the same temperature. Any fluid layer on the surface is at the same temperature, but what about this layer of the fluid? What about this layer? This is a different temperature. This is a different temperature, so that causes temperature gradient. Yes or no? That causes temperature gradient in the fluid. That causes temperature gradient in the fluid. Yes or no? So heat transfer occurs through solid via conduction, but as in the fluid is concerned, in the fluid there is a temperature gradient and the fluid is stationary. There should be convection or conduction. This is stagnant fluid, my dear student, but there is a convection is there. Why? Why convection? Listen, because listen carefully, because actually the fluid is not stagnant, my dear student. There is a convection is there. Listen carefully, everyone. That's very important, because let's say this is the surface here. This is surface, and this is the fluid layer. First layer, second layer, third layer, like this. Clear, beta? Now, when the fluid get heated, this is at temperature of, let's say, 100 degrees Celsius. This is at 98. This is at 90. This is at 80, like this. So that temperature difference causes the variation in density of the fluid. Listen. This variation in temperature in the fluid causes the variation in density as well. This variation in temperature of the fluid layer causes the variation in density. Yes or no? As you know, in the fluid mechanics, I told you density is inversely proportional to temperature, either for liquids or for solid. For the gases, rho equal to P upon RT, Pm upon RT. But for liquid, there is no any particular equation is there, but density is inversely proportional to temperature. When the fluid get heated, the density fluid become lighter. So the fluid layer which is just on the surface will be at higher temperature, then its density will be lowest, and the fluid at this layer will have low temperature comparatively, then their density will be higher. Then that fluid will try to come down and that fluid will try to go up, because higher density fluid will try to come down and lower density fluid try to rise because buoyancy force will develop here. Yes or no? I told you in the fluid mechanics, due to variation in density there is a buoyancy force, and that's called as convection current, and this is called free convection or natural convection. Is this clear? Now, initially the fluid was stationary when there was no temperature gradient over there. When there was no temperature gradient, every fluid layer all at the same temperature. Every fluid layer initially, when I just keep start heating, then initial temperature were everywhere 25 degrees Celsius. But when we kept on a heating rod or on heating surfaces, now the bottom layer of the fluid is at temperature of 100 degrees Celsius, and that causes temperature gradient, and this temperature gradient causes the density gradient, and due to this density gradient there is a buoyancy effect is there, and due to this buoyancy force the high density fluid will come down and the low density fluid will go rise, and that causes the convection current. Yes or no? So this convection current will create the induced motion in the fluid. नहीं, हम ले चलेंगे अभी, ना बनाओ, कोई बात नहीं. क्लियर? ये क्लियर हुआ? इज दिस क्लियर दीपिका? There is a current is na, because obviously if I'm talking about the different layer of the fluid, so obviously this layer is at 100 degrees Celsius, this layer is at 90, this is at 80, this is at 70, this is 60. Then more temperature, low the density. The density of this fluid which is on the bottom surface will be lowest. That will be go up, it become lighter, and the vacant space is going to be full by the high density fluid. This causes a current in the fluid. This causes a current in the fluid, and that current is induced in the fluid because of difference in density caused by difference in temperature, and that is called as natural convection. Then in this case again the fluid become in the motion because of this convection current. Yes or no? Although it's not enough as compared to when we are going to induce the motion due to any external forces. As compared to external force, let's say एक तो मोशन ये इंड्यूस हुआ, एंड वंस आई एम गोइंग टू यूज spoon, then obviously the motion induced by the spoon is much more than the motion induced by the natural phenomena, which is because of buoyancy effect or because of density difference. है कि नहीं? So what I am saying to you, in this case whatever energy transfer on the wall at y equal to 0, again at y equal to 0 means in this example whatever the fluid get heated on the wall, whatever fluid is going to be heat on the wall is directly through conduction, because on the layer of y equal to 0 on the fluid layer on the surface of solid is stagnant, then heat transfer is via conduction. But in the remaining fluid the heat transfer is via convection, because now the fluid is in the motion. Is this clear? So here in this case Q conduction should be equal to Q convection, again the same phenomena as I told you here, Q conduction equal to Q convection. Now the question, I think one question would be arise in your mind ki, sir, if this is the case, then in the fluid there will be never conduction. In the whenever I'm talking about the fluid, either it is stationary or is in the motion, there is always convection is there, because even in that case the fluid is stagnant, still due to difference in temperature this causes the difference in density, and that causes induced motion, and that causes the convection, heat transfer. Question arise हो रहा है नहीं हो रहा है in your mind? Then what is the meaning of saying conduction in the fluid? Because whenever we heat the fluid, then that causes the temperature difference, and that temperature difference causes the different density difference, and that density difference causes the induced motion in the fluid, and then that will responsible for the convection heat transfer. Yes or no? But it is possible, sir. How it is possible? Listen, I am providing two example. Let's say this is the plate is there. I am going to consider fluid is in between the plates. It's top plate, it's bottom plate. Two plate is there, top plate and bottom plate. Top plate, bottom plate, and in this the fluid is enclosed. There is no bulk motion is there. Fluid is stationary. Clear? In this case the top plate is at 100 degrees Celsius maintained, and bottom plate is at 120 degrees Celsius. Here top plate is at 120 and here bottom plate is 100 degrees Celsius. Clear beta? Same fluid is there. Same fluid is enclosed between the two parallel plates, only I change the temperature of the plates. Now tell me, what is difference in these two? Here the bottom plate is at 120 and top plate is maintained at 100 degrees Celsius, that causes the difference in temperature in the fluid as well. This fluid layer, this fluid layer, this fluid layer. Obviously, any fluid layer on the bottom is at 120 and any fluid layer on the top is 100 degrees Celsius. Yes or no? And that difference in temperature means bottom fluid, means any fluid layer which is just on the surface of bottom plate will be at 120 and any fluid layer on the top surface of the plate will be at 100. That causes the difference in temperature and that causes difference in density. Means high temperature fluid will have low density, that will try to rise up, and the low temperature fluid will have high density, that will come down. That causes the bulk motion in the fluid. Yes or no? That causes the bulk motion below, because the fluid at the bottom plate, fluid adjacent to the bottom plate will have high temperature. Since they are at high temperature, then obviously their density will be lowest, and any fluid layer on the top surface is at the lowest temperature at of 100. That's why its density is highest. That will come down and that will come up. That causes current in the fluid. Then in this fluid the heat transfer is via, in that fluid the heat transfer is via, tell me please. In that fluid the heat transfer is via convection. Yes or no? Q dot convection. Convection, Deepika, convection, because now the fluid is in the motion, it's free convection, yes, or natural convection we should say, because convection is when the temperature gradient, here dt upon dx is going to be exist now. When temperature dt upon dy, if it is y here, then dt upon dy I should say, temperature gradient is going to exist in the fluid medium where the fluid is in the motion. The convection is the phenomena of heat transfer between the surface and the fluid. Here the fluid is in the motion. On this surface the fluid is in the motion. Nah? If you go for definition, what the convection is the heat transfer between the surface of solid and the fluid flowing over it. The surface solid and the fluid is in the motion. That's why there is a convection is there. What about this here? In this case, the first layer of the fluid is at 100 and the top layer of the fluid is at 120. Then which fluid have high density? Tell me please. Which fluid have high density? Which fluid have lower density? Upper. Then will there be any convection current? I think here the fluid layer will not displace. Why? Because heavier density fluid is already at the bottom and the lighter fluid is already at the top. There is no convection current. There is no current is there. No current will develop. No bulk motion is there. Only molecular motion is there, but there is no bulk motion. In this case the heat transfer is via, tell me. In this case the heat transfer from high temperature to low temperature is via Q, purely conduction only. Yes or no? So even this is the fluid, but the heat transfer is through pure conduction. Clear beta? Means anyhow, if we are able to cut the bulk motion in the fluid, that heat transfer in the fluid via conduction. So please can you tell me in which case the rate of heat transfer is faster? Same fluid, same thickness. Here it's 1 millimeter thickness. It's also 1 millimeter of thickness is there. Temperature difference is also here 120 minus 120. Here also 120 minus 120. Temperature difference is same. Thickness is same. Fluid is same. But still the rate of heat transfer is faster in the convection. Why it is faster? Because of motion in the fluid. My dear student, whenever the fluid in the motion, that fluid motion causes that fluid motion. In the first case, why is there? Why in the first case more heat transfer is there? Even the thickness is same, even the temperature difference is same. Because of motion in the fluid. No, molecular motion is always there, but that molecular motion is going to be increased by the convection current. है ना? So I will show you my dear in later section कि whenever there is a velocity gradient, because here the velocity gradient was 0, du upon dy was 0, but here du upon dy will be there, is non-zero, yes or no? Because now due to natural convection current there is a velocity gradient, and velocity gradient that velocity gradient will increase the temperature gradient. More the velocity gradient, more the temperature gradient. Clear beta? More the velocity gradient, more the temperature gradient. So whenever there is a velocity gradient, and how it is possible, it's very common sense to say, for example, let's say this is the flat plate is there. Try to understand why velocity gradient physically, why the velocity gradient will increase temperature gradient. Now listen. Let's say one case when the fluid is stationary. When the fluid is stationary, then obviously the first layer and second layer and third layer, I'm talking about two layer, first and second layer. This layer of fluid is at 100 degrees Celsius. This layer of fluid is at, let's say, 80 degrees Celsius. And this, let's say this thickness is of 1 millimeter. Then what is dt upon dy? Then dt upon dy is temperature difference कितना आएगा? Minus of 20 upon 1 degree Celsius per millimeter. Yes or no? This is the temperature gradient. Means at 1 millimeter distance temperature drop by 20 degrees Celsius. This is the temperature gradient. Yes or no? This is the case when the fluid is assumed to be stationary. But when the fluid, and here velocity of the fluid is same here, means fluid is not moving. But when the fluid is in the motion, what happened? When the fluid is in the motion, then there is always one fluid is there whose temperature is lower than this. Always the new fluid. That fluid is going to replace by another fluid, another lower temperature fluid. Yes or no? Bolo. When the fluid is in the motion, then that fluid will be replaced by completely lower temperature fluid. Yes or no? Tell me please. Always the new molecules of the fluid will come into picture at the same position. Low temperature fluid will come at this position when the fluid is in the motion. When the fluid is in the motion, when the fluid is stationary, then there is no motion is there. Always at this layer temperature of the all fluid is at 80 degrees Celsius. But now when the fluid is in the motion, then the fluid is going to be replaced due to bulk motion. So now the another lower temperature fluid will come here. Now its temperature is now, let's say, 60 degrees Celsius. Low temperature fluid. So due to fluid in the motion, then since the fluid in the motion, then what happened? That fluid is going to be replaced by the another lower temperature fluid, because fluid is in the motion, and that increase the temperature now from 100 minus 60. Now it's 40 upon 1 millimeter degrees Celsius per millimeter. Now temperature gradient will get increases. So that will increase the velocity gradient. Has been, whenever the fluid is in the motion, that increases the velocity gradient, and that increases the temperature gradient as well. Yes or no? And when the temperature gradient will get increases, the rate of heat transfer will get increases. Yes or no? Bolo. When the fluid in the motion, that will swept away the older fluid and will come with a new low temperature fluid. And due to this replacement, always the new fluid will be in there, and that will increase the temperature gradient, and and hence it will increase the rate of heat transfer. Clear? Bolo. And this is the reason why, if you want to cool your hot boiled egg, once you kept in the simple without any fan in simple atmosphere where there is no any bulk motion is there, and when you keep the same boiled egg in a air where in a fluid medium where air is flowing over it, in which case the rate of heat transfer is faster, in which case the egg will cool faster. Here there is no any bulk motion is there, fluid is stagnant, velocity of the fluid is zero, velocity of the fluid is zero, and here velocity is moving, fluid is moving with velocity of 1 meter per second, and here velocity is zero of the fluid. Obviously in this case, why? Because that will increase the, then what should be answer? Answer should be, sir, in this case the heat transfer, here also convection is there, here also convection is there. Listen, here is also convection, heat transfer through convection, here also convection is there. Why convection here? Because there is a any fluid layer on the surface of solid will have high temperature, and any fluid layer away from the surface is at low temperature. That causes the density difference, and that density difference causes the buoyancy effect, and due to buoyancy effect there is a convection current is there. Here there is a free convection is there, there is a free convection, but there is a forced convection is there. In the forced convection, there is a forced convection. Is this clear? It's a forced convection is there. So what is the difference the free and forced convection? In the free convection, the velocity of the fluid, or you can say the in the free convection, whatever the motion of the fluid is there, its velocity is less than 1 meter per second. Less than 1 meter per second means induced velocity, or you can say the velocity induced in the fluid by the free convection is less than 1 meter per second. While in the forced convection, velocity is very more than 1 meter per second, and that's why more the velocity, more the velocity gradient, more the temperature gradient, and more the faster the rate of heat transfer is there from the wall. Is this clear? Yes, Deepika. The velocity of the listen, what is the difference in the free and forced convection? In the free convection, obviously rate of heat transfer is lower as compared to forced convection. Why lower? Because the motion, because the velocity of the fluid induced in the fluid via free convection or natural convection is less than 1 meter per second, while in forced convection the velocity of the fluid is much more than 1 meter per second. That's why the velocity gradient is very large in the forced convection as compared to free convection, which causes the more heat transfer rate in the forced convection as compared to free convection. Clear? But either free or force, always on the wall where the fluid is stagnant, the heat transfer is through via conduction only. Because even the motion is there either free or force, because due to no slip condition, always the fluid on the wall is stationary. Then on the wall the heat transfer via conduction only by the fluid motion we are increasing the heat temperature gradient. That's why the rate of heat transfer via conduction get increases. Is this clear? Try to from the for the conduction there is a law of Fourier's law. Q is equal to, I will discuss in the next lecture, minus k into dt upon dx. It's by Fourier law for conduction. So Fourier's law says the rate of heat transfer via conduction is proportional to temperature gradient. Is this clear? The temperature gradient at the wall always either free or force. Always at the wall the heat transfer via conduction is there. But since rate of heat transfer via conduction is proportional to what? Temperature gradient, and temperature gradient will get increased via fluid motion. Is this clear? Temperature gradient will get increased via fluid motion. So please tell me, it is temperature gradient at the wall at y equal to 0, dt upon dy at y equal to 0. Let's say y, I am talking about y. Listen, so temperature gradient at the wall is higher in the free convection or forced convection. As I told you via this example, here temperature gradient at the wall is minus 20 and here temperature gradient is 40, minus 40. The temperature gradient in the wall, as we have seen, when the velocity will be increased or when the fluid is motion, higher the velocity of the fluid or higher the velocity of the fluid, higher the temperature gradient and higher the velocity gradient. Higher velocity gradient will responsible for high temperature gradient, and high temperature gradient means higher rate of heat transfer by conduction through wall, and that heat transfer through wall is going to be transported in the remaining fluid via convection, because at the wall fluid is stationary, but in the rest, in away from the wall, the fluid in the motion. Then whatever heat transfer via conduction is going to be propagated in the rest of the fluid via convection. Yes or no, Deepika? The only difference in both cases, either free or force, rate of heat transfer via conduction at the wall is equal to convection in the fluid. Listen, in both cases I should write Q conduction at wall is equal to Q convection in the fluid, in rest of the fluid. But what happened in the forced convection? In the forced convection, Q conduction is getting increases. That's why Q convection also get increases. Are you getting it? So that's why I'm saying convective heat transfer or rate of heat transfer in the forced convection is stronger than the free convection. It is just because of temperature gradient at the wall getting increased when the fluid is in the motion. So I will also discuss in the and why temperature gradient will increase by the velocity gradient. I had told you कि when the fluid is in the motion, then the older fluid will replaced by the newer fluid, low temperature fluid, comparatively low temperature fluid. It means the high temperature fluid will be replaced by the every time the surface is exposed to the new fluid, which temperature is relatively lower than the previous, that will increase. Means listen, when the fluid is in the motion, then every time the surface is exposed to the new fluid as compared to when the fluid was at the rest. Yes or no? And when the fluid is exposed for the new fluid, then there is always a velocity gradient, and that causes the temperature gradient. Clear? So high the velocity gradient will responsible for high temperature gradient, and high temperature gradient, that's why the higher rate of heat transfer by conduction at the wall, and that high rate of heat transfer through conduction at the wall is going to be transferred in the rest of the fluid by convection. Yes or no? Any other doubt? So Mr. Professor, simultaneous here in this case there is now simultaneous, but simultaneous conduction and convection is there, like in this case. I told you, just if you are going to heat the bar like this, if you keep heating, let's say you kept this bar on the wall, this wall is at temperature of 100 degrees Celsius, okay? And you kept this bar here. What happened? At the wall, let's say this is X here. At X equal to 0, the heat transfer in the bar is via only conduction at 0. Q equal to Q conduction. But at any distance X from the wall, यहाँ पे at X, total heat transfer is equal to what? बोलो. At X, Q at X equal to Q conduction प्लस Q कन्वेक्शन. यहाँ से कंडक्शन होगा बट यहाँ से कन्वेक्शन भी तो होगा. Q कन्वेक्शन, this simultaneous conduction and convection both is taking place. Clear? So this is what simultaneous. But within the solid or within the fluid, it's not possible. If I'm talking about only fluid, Mr. Prasad, in only fluid is there is simultaneous conduction convection? No, it's only because actually what happened at the wall, again the same concept is there. At the wall, on the surface of the wall, the heat transfer is via conduction, but that is going to be same as the convection. Q conduction equal to Q convection, because this is similar to this is the wall. And any fluid layer on the surface, this is the fluid flowing here, any fluid, then at the y equal to 0, heat transfer by conduction, and that is going to propagate in the convection. Yes or no? Similarly, within the solid wall is the heat transfer by convection? No, it's only conduction, because in the solids convection is not possible. Convection is only in the fluid. Okay. And in order to carry out the pure conduction in the fluid, you must restrict the bulk motion. And how I can restrict? I had shown you through this example, this through example. कुछ क्लियर हुआ कंडक्शन कन्वेक्शन में? Means in order to have a pure conduction in the fluid, we should assume that there is no bulk or microscopic motion. The physical mechanism of conduction is most easily explained by considering a gas and using idea familiar from your thermodynamics background. Consider a gas in which the temperature gradient exists and assume there is no bulk motion or there is no any microscopic motion. Microscopic motion is always there. We can't ignore the microscopic motion, yes, no? But can you ignore the microscopic motion of the molecules in the fluid? No. Clear, beta? So I will discuss the Fourier's law, and in the later section also I will discuss how the fluid motion will affect the rate of heat transfer. Because ultimately we have seen when we used to eat samosa or any hot objects, then we used to blow from mouth. We used to blow air from mouth, and that air is actually what force fluid motion. By blowing air through mouth on any hot samosa or any hot object, the only purpose is to increase the rate of heat transfer. When we used to blow the air, then what happened? That we are actually increasing the temperature gradient over the steps. And when the temperature gradient increases, then heat transfer on the wall will through conduction will get increases, and then conduction to convection in the rest of the fluid, convection also get increases. Clear, beta? So now from today onward, whenever you used to blow air in any hot object or any hot eating object, and when you used to blow air, then basically what you are doing, you are actually replacing the molecules, older molecule with the newer fresh molecules, that increase the velocity gradient, and that will increase temperature gradient. So velocity gradient means motion. That's why I told you, listen, how much importance of the fluid motion is there in the study of heat transfer. Yes or no? Whenever I'm talking about convective heat transfer, then always the fluid motion will play very important role. Yes or no? Whenever I'm talking about the heat transfer in the fluid, you can imagine how the fluid motion is important. Yes or no? Because that velocity gradient increases temperature gradient. So fluid properties and fluid motions will play very important role in the study of convective heat transfer. And rate of convective heat transfer will strongly influenced by rate of heat transfer through convection, or rate of convective heat transfer in short is strongly influenced by fluid motion. Is this clear? And fluid properties. ठीक है बेटा? So basically, and if you want to cool the hot boiled egg, if you want to make for eating, then you used to blow air from your mouth, or you used to drop in the water. By dropping in the water, you are increasing the temperature difference. Or by blowing the air, if you keep the same boiled egg below the fan, then obviously that egg will cool faster. Basically, what the fan does, fan do not make any miracle. It simply increases the velocity gradient on the surface of the axle, and that velocity gradient increases the temperature gradient, and consequently that temperature gradient at the wall increases. It means the rate of heat transfer via conduction at the wall. Whenever I'm talking about conduction, this should be at the wall. Rate of conduction at the wall get increases, and that rate of heat transfer through conduction at the wall is equal to rate of heat transfer by convection in the rest of the fluid will also get increases, and then the time to cool it will also get decreases. Is this clear? Any doubt you have, you can ask me. So today we have only discussed about the basics. Even today I had not told you any laws. Simply I told you basics of the conduction, convection, radiation. And now to this concept you can relate the numerous example of conduction, convection and radiation is there in your daily life. Suppose you make a chapati, and if chapati is very hot, then you can't make it directly. Then what do? Either you blow air, or you should expose to the atmosphere. Then what happen? Air is flowing over it. That causes the temperature gradient. There's also, even if a chapati, there is a temperature gradient will form here. Means temperature boundary layer will form. Velocity boundary layer as well as temperature boundary layer will form. And when you blowing air, you are basically increasing the velocity gradient, and that consequently increases the temperature gradient, and that increases the rate of heat transfer. Clear, beta? Thank you so much.